The graph of a rational function f is shown below. Function f has the form f of x is k over qx with the following properties. F of x has no x-intercepts or vertical asymptotes. Now, the no x-intercepts is confirmed at the bottom here by k being a constant. If k is a constant, and it's a non-zero constant, otherwise this would be just f of x equals 0, and it wouldn't look anything like this, then the top cannot be 0, and therefore it won't have any zeros. The fact that it has no vertical asymptotes tells us that this quadratic never takes the value 0. This part is just telling us that the x-axis is a horizontal asymptote. F is symmetric about x equals 3, and we can see that on the graph. And that suggests to me that q of x will contain x minus 3 squared. However, it can't just be that, because when x is 3, this would be 0, and we would have a vertical asymptote. So we must be adding something here. So q is a quadratic. I've actually just used that fact over here. And so let's see what we could possibly do. Well, our first thought is just to put a 1 here, x minus 3 squared plus 1, and then see what we can do with the top. Now, if x is equal to 3, this would just be 1 on the bottom. And when x is equal to 3, I can see that f of x is equal to 2. So that would mean putting a 2 on the top. But does that work elsewhere? If not, I'm going to adjust the 1 and the 2. I'm pretty confident about the x minus 3 all squared because of the symmetry about x equals 3. So what about when x is 2? That would be 2 over 2 take away 3 squared plus 1. Well, that's negative 1 squared, which is 1, add 1. This would be 2 over 2, which is 1, and that's correct. And it also goes through this point here, because we'd have 2 over 4 minus 3 squared plus 1, and that works as well, with f being equal to 1. So this appears to be our defining rule.